Welcome to another edition of Micro Welding Tech, the only podcast dedicated to welding at a micro scale. Subscribe today to stay on top of what's new in micro welding technology.
So welcome to our next episode today. We're excited to talk about, this is one of the biggest questions we get, Dave, about welding and about jewelry specifically, but a lot of customers are really interested in the differences between pulse arc and laser and why one over the other and how they kind of work together. So the first question I have for you, the questions people ask us, should they purchase a laser welder or a pulse arc welder? So what is the difference really between those two technologies?
Yeah, great. I'll break it down more on like a fundamental level. The arc welding, if we look at a pulse arc welder, it's basically TIG welding on a very small micro scale. In order to do that, we're using electricity. So we have a positive and a negative connection. And when they come together, that's what's going to spark and make the weld. To go the next step further, you'll probably see on the arc welding we use tungsten electrodes. That's your positive connection. And then we have, that's your negative. The tungsten electrode is your negative connection. And then we use a grounding clip, an alligator clip, a metal tweezer of some sort. We'll clip onto the piece. And when you come close, when you've got your electrode, your needle, that sharp needle, and your grounded piece, when they come close, that needle is going to touch. Then that needle is going to pull back and create a gap, and the electricity actually jumps from the needle and hits the piece. So that's the basic, most simplest way of breaking down what's happening in that arc process. When the electricity is jumping from the needle and hitting that piece, it has a very high intensity. That arc is generating a lot of heat, and it's enough to make a spot weld on the surface of whatever that grounded piece was. When you look at laser welding, it's completely different. Instead of using electricity, we're now using light. That light is collimated, so it's all traveling in the same direction, using a flash lamp and a special rod, a crystal. And when the light enters that crystal, it makes it all go in the same direction. It comes through, the laser light is bouncing back and forth. It comes through through an optical path, and then it goes through a focusing lens where it converges and brings that light, so it all converges into one point. And again, it has a lot of intensity, a lot of energy into it, and that energy, that light, which is really kind of fascinating, that light is coming in at such a concentration and intensity that it's able to be very hot and overcome the melting temperatures, the melting points of these metals, and again, create tiny little spot welds. So they're two very different technologies, but the end result of the two is very similar. If you look at what the end result, if you didn't know what you're looking for and you just looked on the surface, I could take two identical pieces, make two welds, one with arc and one with laser, and hand them to anyone, and chances are they're not going to know which technology made which weld.
Interesting. Yeah. So obviously in the marketplace we see a lot of emphasis on laser, and a lot of people talk about the benefits and how cool they are, and that they're kind of the wave of the future. So why does laser get so much attention?
I think lasers are they're kind of fun. They're kind of newer. They definitely stand out, right? If you're looking around and you see a laser machine, you know, just with the chamber and the microscope and just the design, they're kind of futuristic looking. I think there's a natural draw just from how they look. They're easily identifiable. I think, though, when you look at it, there are a lot of just, when you sit down and use it, there's a lot of benefits of a laser. They're just fun to use. You're just looking through a crosshair, whatever in the crosshair, that's where the weld is going. If you can see it, you can weld it. So in that way, lasers are a very fun, very easy to use machine. Anyone that's used a laser will tell you it's just fun. You're using light to melt metal. I think that kind of could blow your mind if you sit down and process for what it actually is. So I think lasers do get a lot of hype. There is a lot of demand for them. The process of using them is simple. If you're doing the same job, if you're doing manufacturing, you just need to weld. The lasers, there's really no downtime from one weld to the next. In fact, you know, lasers, you can fire multiple shots per second, up to 30, 40. I've seen one recently that goes up to 50 welds in a second. I don't know who needs to be going that fast, but the laser can do that. And depending on the design of the machine, you could do that for 8 hours a day. Just have it on and just go. So lasers are very, very cool machines.
That's crazy. What, I mean, obviously you talked about a little bit of the benefits of a laser and why they're cool. What are some other reasons from a user standpoint? What are advantages to using a laser?
Mm-hmm. So one thing I really like about the lasers is I'm going to say that it's contactless. There's no contact involved. And I only share that in contrast to what the arc welder is. The arc welder is you have to clip it and you have to touch that needle. So that process, there's a lot of contact happening. When I switch over to the laser welder, like I said earlier, whatever I see is where it gets shot. So I can hold that piece, I can spin it in my hand, hold it in my hand, move it around, and every time I step the pedal, that's when I get the weld. So in terms of that aspect, that's a unique feature that I love about the lasers. As long as you can see it, you can make those welds. And they work with a lot of different metals. Whatever you see, whatever metal you see in there, it's going to take the hit. Now there's certain metals that maybe are more difficult, but the majority of metals you can weld with a laser welder and just lay the bead and run the bead, and it just goes.
Interesting. Now, obviously, technology has changed a lot over the time, right? I mean, in the last 10 years, technology in phones and everything is advancing at a fast rate.
Right.
So, and the same would be true about welding technology. With that being said, what's the differences and or advantages of the pulse arc, compared to a laser?
Yeah. So, again, minus the one difference with the contact versus the crosshair. If we get into the metal side of things, you can weld any metal with both machines. Certain metals will weld nicer or easier with one or the other. Specifically when it comes to the laser versus pulse arc, the pulse arcs will do a lot nicer with shiny metals, with reflective metals, with conductive metals. So particularly you've got silver in that group, you've got copper as another one in that group, and the reason why arc kind of has an advantage when it comes to those types of metals is because the laser beam, when it hits something shiny, it's going to have the tendency to just reflect and bounce off rather than affecting that metal and making a weld, making a puddle. If you do get it to hit, you're going to have more intense power, because the other thing is if that laser beam just hits it and the metal absorbs it, chances are they're so conductive that heat is just going to transfer instantly throughout the piece, and the whole piece will warm up rather than one tiny spot getting hot enough to go liquid. When it comes to arc welding, that arc weld, when that needle pulls back and you create the puddle, it's going to melt that section there, and it doesn't have limitations of conductivity or reflectiveness to deal with. Electricity is going to zap it like a lightning bolt and just hit it, and that spot's going to puddle and liquefy and make a weld. So that's one of the big advantages of a pulse arc welder when it comes to it. If we look one step further at just how the puddle is created, I would say typically a generalized statement would be that the arc welders are going to be have a little more penetration, shot for shot. If I just do one shot for one shot, your arc weld, just because of the technology and how the weld is delivered, you're going to get deeper welds on an arc welder than on a laser. Not to say that you can't achieve that with the laser. It's just looking at the two technologies. There are slight variations in them. If you had the laser, you could just increase your time a little bit longer and do a series of shots rather than just one shot with the arc to achieve the same thing. Just once you get your hands on the two technologies, you'll see it. Like I said, going back to the beginning, if you give me two pieces and I make a weld, it's going to be hard for you to know without knowing the technology which weld was created with what machine.
Sure, yeah, that makes sense.
Truthfully, they're that similar.
That's similar. So, question: as you look at this from a new user, right? Obviously, if you're comparing these technologies, they've both been around for a long time. You got people in both camps, right? People who are big pulse arc fans, people who are big laser fans. As a new user coming into this, which technology is easier to grasp and understand and learn how to use and start making money with?
Perfect. I would say the beauty to answer that one, which one's easier for a new user? I would say the beauty is that both technologies can be easy to learn. I get asked this a lot, right? What's better, this or that? I always flip that question around and say, well, the best answer is what's better, not pulse arc versus laser, but what's better for you? And then that takes a lot of probing questions to figure out what it is you're doing. Are you doing all copper and silver? You could get it done with the laser, but I'd initially on the surface say you want an arc welder. That similar thought can translate into what's better for a new user, what's easier to learn. We all have our own backgrounds, our past experiences. Those are all going to play a part into what we want to use now. Some people might be more comfortable with the tactile feedback of touching that piece to the needle, knowing that that's where the weld's going to happen because they're touching that spot where the weld is. Some people might be more used to working with the microscope and working with the crosshair, and that just naturally speaks to them. They can hold their hands in the chamber, spin the piece, and make the welds. It's not, neither one of them is horribly difficult to learn. And what's even nicer about this, if you have time on one machine or the other, let's say you have 10 years experience on a pulse arc machine, you'll be able to sit down and use a laser with minimal training. Give yourself a couple minutes, up to an hour, just to learn the differences, and then you're off. You don't have to have years of experience to get good on the laser. You have that years of experience on an arc machine. Now you're just tweaking it. And it goes the other way as well. If you're a proficient laser welder with years of experience, give yourself, like I said, 15 minutes to kind of mess around and understand the slight variations, and you'll be able to be doing live jobs within minutes. Adding wire, building sections, filling holes, joining pieces. The two go hand in hand.
Awesome. You mentioned there the controls, that they're very similar. What are the energy controls on each, and how are they similar and different?
Perfect. Let me start with the laser, because there's a few more at play. Not that those don't exist with the pulse arc, but it'll make sense why I'm going to do this. If you sit down on a laser machine, you're going to have your power, which is how much charge, how much punch the weld has. You're going to have your time. That's how long is that weld happening. You've got your spot size. That's important because it takes those two variables, the power and the time, and it kind of determines the intensity or the concentration of that energy. And then you've got frequency is another one. How fast are you making welds in sequential? So like, are you making 1 per second, or are you doing 30 per second? That's an important one to know as well. If you go 30 per second, your piece is going to get a lot harder than if you do it hotter than if you're doing just 1 per second. Power and time, you take those two together, that's the total energy that goes into it. Depending on the metal characteristics, you may have one that needs a really out-of-the-gate high peak energy, and then you turn it off real quick. So that would be a high power and a low time. Other metals or other applications may require you have a very low time, but you keep it on. It's kind of a slow burn. You'd have a low peak and a long time. So those two, there is a combination of those two that kind of gets, you have to take some time to get familiar with it. I would say between the two though, I would say your time is actually the more important variable to mess with. A lot of people think, oh, this is a bigger piece, I need to crank my power. I would argue that time is the more important variable to play with on that one. Your spot size, you could have a lot of energy and you could condense it into a very small spot, and that's going to basically drill a hole or punch a hole through something. You could go the opposite, have a very low, well not very low, but lower settings on your energy, time and power and time, and open up that beam spot, and you can use that to your advantage to smooth and polish metal, kind of knock off rough edges and do some finishing work before you have to take it to a file or a grinder or a wheel or something. So the laser gives you a lot of control with all those variables. Knowing that there's those 4 variables, let's now switch to the arc side. Depending on the machine that you have, most of these parameters can be simplified and combined into one slider. And that's the beauty of the arc machine. Really, if you talk to the sales team, or you get your hands on an arc welder, we'll tell you, once you set up kind of the background settings, we really only recommend you mess with the power slider. And that's because that power slider, well, it controls the power that the laser has. The time is automatically adjusted based on the power, so that's fun. The spot size will automatically grow. More power will give you a bigger spot, less power will give you a smaller spot. So those three variables are now combined in the back end when you're using an arc machine, an arc welder. And then the speed is a separate individual variable that you can slide. You can control, depending on the machine, up to 5 welds per second. So I like the arc machines, the arc welders, for that aspect. truthfully, they're a little bit easier to use because you don't have so many variables that are dependent on you to input for every job. You can get by just focusing on that power slider because the design of the product, everything ties into that in the end.
Interesting. Now, obviously, as a new user, they're kind of looking at these technologies, obviously advantages, disadvantages. When it comes to price, what's the difference between a pulse arc and a laser?
Yeah. So you'll see a significant difference between the two. The arc welders, they range between, mid 2000s, like $2,500, $2,300 I think is our entry point. 2,800 with a microscope. And we've got different models depending on what you need that go up to 8,000 or sometimes even 12,000 for an arc welding machine. And that 12,000 price point, well, on the laser side, we start at about 4,000 for our most simplified laser welder. That one is really just getting you the laser technology, but there's not a lot of power. It's limited in what it is, but what you get for what you pay for, there's not a better deal. 4,000 is the starting point on a laser. It goes up to 10, goes up to 15, goes up to 20 plus. So it depends on what you're looking for, power, feature set, things like that. If you go for a joule comparison, you're looking probably at, let's just take a 150 joule machine. We have a 150 joule arc welder for in the mid 5,000s. 150 arc machine, laser welder machine is going to be maybe 18,000. So there's a bit of a jump in price. A lot of people ask, well, why? It's more expensive, it must be better. If you break it down, though, the componentry and just the cost of what you need to build one of these machines, that's where the retail price, you see the difference. It just takes a lot more of high-end components to get a laser to do what a laser does. And so the cost to build that is higher, so therefore the cost for the end user to purchase it is also higher. In this case, this is one where I wouldn't say that if you compare a $4,000 arc welder to a $14,000 laser welder, it's like this is super inferior or super superior. It's just a different technology, and the cost comes is based off the difference in the cost to build.
Interesting. Now, obviously, if there's cost to build, is there a difference in the maintenance between the two machines? Does one cost more to maintain?
Yeah, great question. When it comes to the arc welders, the only thing to maintain are those needles that I started talking about in the beginning. It's a tungsten electrode. It's maybe 3 inches in length, 3 inches or so. And you want to keep that sharp. So over time, as you weld, that tip, you might lose the tip, it might get blunt. You might stick the electrode, in which case there's some contamination, some metal splashing back on the electrode. Whenever that needle's no longer sharp and clean, you want to go redress it. You want to go sharpen it again. And so you'll stick it on a diamond wheel and you just rotate it in your fingers and get a point on it again. One needle will give you 5, 6, 7,000 welds. After that time, it's just so short that you can't keep grinding it and using it, so you throw it away and you replace it for $3. So that's really the maintenance and the cost associated with an arc machine. On the laser side, you have a lot less frequent maintenance, meaning you're not constantly grinding that needle throughout the day. But what you will have is annual maintenance on that machine. Annual maintenance meaning if there's filters involved, you want to change the filters, the air filter or the water filter. And the other big one is the flash lamp. There's a light bulb inside of a laser machine that produces the light, and those have a life expectancy. So those will have to be replaced. The cost to replace those, that's, $300, $400, $500, $600 replacement, depending on the size of the bulb and the manufacturer. And typically, that's not even an annual thing. You could get multiple years on a light bulb. It just depends on how much it's flashing. How often are you using it? So I would say with the arc machines, it's a cheaper but more frequent maintenance that you're looking at. On the laser side, you can go a lot longer without the maintenance, but when it is, it's a bigger price. It's a bigger check that you're going to have to write. In the end, though, truthfully, they're both pretty affordable in terms of a maintenance and upkeep. The biggest difference between them is just that upfront purchase.
Interesting. Is there a difference? Obviously, as a kid, I remember seeing lasers, and they have all kinds of warning labels, and don't get them in your eyes and stuff. So, is there a difference in safety consideration? Right? Should I be worried more about a laser than I am a pulse arc?
Yes. Yes, I would say that the lasers do come with a more significant potential for harm. These are Class 4 lasers. These are, if the laser beam were to hit your eye, they could affect your vision. There's some significant downside to these. But in order for it to be sellable, there are many different steps of protection and caution built into the machine. In fact, in the USA here, they have to be FDA approved to sell them. And so any laser that you purchase has already gone through and has certain safety standards in place to limit any potential for this. You'll see a lot of them, they have a place where you insert your hands into the chamber, and that is regulated. So there's not large gaps for that beam to escape if it were to bounce off of something inside the chamber and escape. The optics that you look through have multiple layers of filters so that that light could not come back up through the microscope and harm your vision. There's nothing we can do about the laser hitting your finger. If your finger's in the crosshair and you step on the pedal, you're going to get hit. It's going to feel like a hot sting. So that's in place, but everything that we can has been put into place to limit any potential harm to the operator or to someone else in the room. Everything's contained, everything's enclosed to the best that we can. So it's something to consider. If you have more questions, feel free to call in and talk through those. On the arc side, again, we're dealing with plasma, we're dealing with electricity, so there is always a potential for burn there as well. One thing with the arc welders, though, a lot of people, when they first use them, they think they're going to get shocked because it is an electric welder. Luckily for us, when you weld with an arc welder, the electricity is flowing through the path of least resistance. So it's going to follow whatever metallic route is the easiest for it to go. So when that needle touches the piece, it pulls back. The electricity jumps from the needle into the workpiece, whether it be, whatever that metal workpiece is, a ring or a battery pack or whatever it is that you're welding on, a thermocouple. It's going to enter there, and then it's going to look for that grounded clip, that alligator clip, and it's going to go to the ground path and then back into the machine. So there is no chance for you to get zapped or shocked. The electricity is never going to flow into your finger. In fact, if you hold the alligator clip and you touch your finger to the needle, nothing will happen. If you touch the alligator clip and then you slip off and touch your finger, nothing will happen. The only potential danger with an arc welder is that your finger is too close to where the weld will happen and the energy is too high. You could get residual heat from the weld, but you never will get zapped or shocked. Also going back to protection, that arc, when it happens, it does have UV rays. And so if you're looking at the arc, that could over time damage your vision, potentially, if you see it a lot and constantly. Lasers, one bad shot to your eye, I think you're done. An arc welder, I've seen many of arc flashes. It's not comfortable, but I'm not blind yet. Just kidding. Both, though, have multiple steps of safety built in. If you look in through the microscope when you're doing an arc weld, it's got a shutter built in that goes completely black and filters out any UV light, so you're not getting exposed to that. Now, operators next to you on the side or in the room, it'd be good to maybe build kind of a wall or a barrier just to contain the UV flash that's happening, but no long-term major dangers or caution there.
Awesome. As you look at these different technologies from a manufacturing standpoint, and even moving forward into like a fully automated line, is there an advantage from an automation standpoint, one over the other, in like a mass production?
Yeah, typically we will always recommend a laser welder when it comes to automation, semi or fully automation. Just because that laser, it just needs that crosshair, it just needs to know where it's aiming, and then it's going to fire that beam, deliver a weld, and there's not really that in-between maintenance required. The arc welders, our technology has come a long way, and we do have people who have automated arc welding as well. But you have to know that you should plan for some level of downtime to switch out that needle so you have a clean, sharp tungsten electrode during the weld process. Both can be automated, Lasers are easier to automate just because of the contactless and the less need for maintenance in between. So between the two, yeah, we can talk. Every application is different. Like I said, there is time and a place for automating an arc welder. But if I had to give you a generalized one-word answer to which is better, I would say lasers are better for automation.
Awesome. I mean, you mentioned that they've come a long way in both laser and in pulse arc. Those machines have come a long way. As you look to the future of these technologies, do you see one kind of taking more of a market share or becoming more important than the other in the future?
I think that can only be answered on an individual basis. Every application is unique. Every application is different. Really, they both exist today, and I think they both will continue to exist. It's not that one's going to replace the other. It's not that it's one or the other. I really see, and I could show you customers and applications that attest to this, there is a need for both. It's very dependent on the application. Very dependent on the metal type, very dependent on the scale of what's going on. Both exist, both have a place, and I would argue for someone who's just trying to cover their bases and be able to handle any future job that could come up, you need to consider both. What works today for this application may not be the best answer for the application that's coming through your door next month or next year. If you only build around one technology, you're losing out on other capabilities. And that could go both ways. That could be someone who's heavily invested in their micro arc welders right now today. Tomorrow, the laser might be the clear-cut answer. Or the other way around. You may be someone that has 10 lasers in your shop and something else comes through. If you stick to what you know, you can probably get by with it. But you may realize that there's unlocked capabilities and potential by grabbing and looking at considering an alternative technology.
Interesting. Now, obviously, Sunstone is in micro welding, right? We offer both technologies, both laser welders and pulse arc welders. Is there any trend that you're seeing that happen in the recent past between the two technologies?
I would say that the biggest trend that I'm most excited for, as you mentioned in that question, we offer both. And what's unique about us in that scenario is if you were to go talk to someone, let's say laser manufacturer, and you present with them your application and your welding need, that laser manufacturer is going to recommend and highlight the fact that you need a laser welder to solve that problem, to fill that need. And why? Because they're a laser manufacturer, and what can they offer you? A laser welder. If you were to go someone who manufactures and only offers an arc welder with that same application, they'll say, oh yeah, this can only be handled with an arc welder. Why? Because it's what they sell and it's what they have to offer. What I like is that we do offer both. So when you come and you present us with an application or a potential job, or you're looking to buy a welder, we'll take a step back and really look at you and your application and your needs and the advantages of the different products that we have. And then that recommendation isn't based off of what I have to sell you, it's what best fits your needs. And so if I were to look at trends that I'm seeing, one of my favorite trends that I'm seeing is this crossover. And we're getting to that point where the market and the industries are realizing that it's not one or the other. It's, hey, there are two different technologies and I can benefit from both. I was recently, a couple weeks ago, working a trade show at a jewelry trade show. There was a shop and there was 3 jewelers, active jewelers in the shop, and they had one laser machine. And we were just chatting, and they talked about how there's always a queue, there's always a line of jobs waiting to get on the laser. With three jewelers and one laser, you can see how that could happen quickly. And we started talking, and I highlighted the benefits of the arc welder. A, that it's affordable. They could double their welding stations for a minimal investment. B, the fact that they could do different metals with different capabilities at this point, right? Those more shiny conductive metals could be better done with an arc welder. Or simpler jobs. If you just have a quick jump ring that you need to close, if you pop it once on an arc machine, it's done. And you don't need to take up and use time for the more expensive laser welder to do a simple job that's not making you any money. Closing a charm link, no, you're not going to charge extra money because you used a laser welder versus a pulse arc welder. You charge the same. Why not do the simple jobs on this simple machine? And in this case, they did end up buying one or two of our most affordable lasers, so that now every jeweler in the shop has a welder. And then they can break it up and say, actually, I'm doing this job and I need the laser. Can you get by can you do that job on the arc welder? Or they may just sit down and say, hey, I'm using the arc welder. The laser is just free. Anybody can use it. And so really getting into that side of things where you realize that there's more tools available to you, you can maximize your productivity and your workspace.
Awesome. Now, you several times you mentioned, obviously there's not a major advantage to one technology over the other. It really is just dependent on what you're doing. What are some resources customers can use, and what are ways that they can figure out which technology is better for them?
I would say the best thing to do, we've got a few guides, and we'll provide links to them here. We have a few articles that talk about what are the pros and cons, and how do they really stack up? What's the comparison? I think if you do a Google search, I think the document's entitled Pulse Arc Welding versus Laser Welding, which is better. We've got a blog post, but we can highlight that here. That's a great document and breaks down a lot of what we've covered today. Gives a little more detail, some more technical diagrams and specifications. So that's a great starting point. The other thing is, like I said, we offer both. So we are, as you see on the wall behind us, we are the micro welding experts. Call in, ask for the sales guys, and just say, I need to weld this metal in this application, in this industry. What are my options? We can talk you through on the phone. We can do one step better, and we can provide you with free sample evaluation. If you send in your actual parts to our samples lab, we have an arc welder set up right next to a laser welder, and we can weld it with both and do an evaluation and say, based off of this specific one-time application, we're going to recommend this product or that product. If you go with this one, here's the pros. If you go with that one, there's the pros. So we just educate you and let you make the choice that is best for you. Are you more comfortable with that tactile feedback? Are you more comfortable with the crosshair? Is it conductive or resistive metal? Are you doing automation or are you not? There's a lot of factors at play. And we'd love to be there for you as a consultant to talk you through the advantages and the options, and then you get to make the best choice available for you versus talking to a laser manufacturer, you're stuck with a laser. Talking to an arc weld manufacturer, you're stuck with an arc welder. We want to be your solution and your partner when it comes to finding the best product for you.
Awesome. Well, it's been great to talk over this. Obviously, a very common application, very common question we get.
Yeah.
It's been good to talk with you. So thank you. Thanks for listening.
Very good.
That concludes another edition of Micro Welding Tech. Got questions, comments, or topic suggestions? Call or text 801-658-0015. Remember to subscribe today to stay on top of what's new in micro welding technology. Thanks for joining us.